Okay, so as in the last video we have discussed about the equivalent capacitance. What was that? Basically, we before yesterday's video we have discussed about the voltages, right? We were known that in series the potential difference would be different on the every member of the capacitor, however the same charges would be stored, right? If there would be different potential for the each capacitor, then how do we calculate the potential, right? So v1 is equal to q per unit c1, then v2 is equal to q per unit c2, and v3 is equal to q per unit c3, right? And we also discussed that if we want to find the total potential difference, that would be equal to the sum of all the potential differences, right? Then in yesterday's video we started discussing about the equivalent capacitance. We initially discussed when if we replace three capacitors, right? We initially used three capacitors, right? c1, c2, c3, but now we replaced those three capacitors by a single capacitor, right? That was called as equivalent capacitor, and was represented as CE, right, which is equivalent capacitor, which acquires same potential difference and same charges, right? Then we made the diagram of it, because we have merged three capacitors, or we have replaced those a capacitor instead of those three capacitors, right? And we have given it a name of equivalent capacitor, which is represented by CE, right? So if we need to find the total potential difference, that would be of course equal to the ratio of the charge per unit equivalent capacitance, right? So VT, we have already discussed that here. Total potential would be equal to the sum of all potentials. So V1 plus V2 plus V3. So VT is equal to Q per unit CE. We have written this. V1 is equal to Q per unit C1, right? And V2 is equal to Q per unit C2, and V3 is equal to Q per unit C3, right? We were known that charge would be stored on the plate would be same on each capacitor, or on the each plate of the capacitor, right? So Q we have taken as common, 1 upon C1, 1 upon C2 plus 1 upon C3, right? Charge cancelled by this charge, so 1 upon CE is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. Thus this equation showed us that the reciprocal of equivalent capacitor is equal to the sum of reciprocal of individual capacitors when they are connected in series. Alright, so how we gonna find the equivalent capacitance now? We will gonna take or the sum of, or you can say the reciprocal of equivalent capacitor would be equal to when you will be taking the sum of all the capacitors that two reciprocal of those, right? Then you can find the equivalent capacitance. For suppose if you have a three capacitors connected in a series, right? I am generating my own numerical here, so let me write here numerical, right? So I'm making here the diagram first. We have basically three capacitors here which are connected with the positive and the negative terminal of the battery, right? This is 1, 2, 3, right? This is C1, this is C2, this is C3, right? So for suppose voltage you have provided to it as 5 volt, right? And they are storing the same charges, and here the charge is equal to basically 2 microcoulomb, which is equal to 2 into 10 to the power minus 6 coulomb, right? And C1 value we have basically C1 we have 5 farad, C2 we have 2 farad, and C3 we have basically 1 farad. Okay, so now you need to find the equivalent capacitance here. You need to find here the equivalent capacitance. right? So initially you will be writing the formula here. Formula is the reciprocal of equivalent capacitors in series would be equal to sum of all individual, or the sum of reciprocal of all the individual capacitors, right? We have three capacitors, so 1 upon C1 plus 1 upon C2 plus 1 upon C3. This formula we'll be using here, right? Now basically we are finding the CE here. So 1 upon CE is equal to 1 upon C1, we have 5. So 5. Farad is basically a unit of capacitance which we have already discussed, right? And 2 is for C2, so 1 upon 2, and 1 is for C3, so 1 upon 1. Now the reciprocal of this value would be of course 10, right? So 10 divided by 5 is 2, so this would be multiplied by 2. 10 divided by 2 is 5, so this would be multiplied by 5. And 1 divided by 10, or 10 divided by 1 is 10, so here we're going to multiply it by 10, right? So 1 2s are 2 plus 1 5s are 5 plus 1 10s are 10, right? When we're going to add these all, we're going to get 17 upon 10. So this is 1 upon CE, right? Now you need to take the reciprocal of it, right? So basically you can cross multiply it, right? This will be cross multiplied, so 1 multiplied by 10, which will be 10, right? And 17 CE. We need to find CE, so this is multiplying with CE here. When we go there, it will be divided, right? So CE is equal to 10 per unit 17. This would be the equivalent capacitance, right? This would be the equivalent capacitance. Now did you get how we're gonna find the equivalent capacitance? This is very easy. If they are asking you to find the equivalent capacitance in series, what you need to do is you can find basically equivalent capacitance or the reciprocal of equivalent capacitance by adding all the, or by adding all the reciprocals of individual capacitors, right? Basically that would gonna lead you to find the equivalent capacitance. And this basically showed us what? This showed us, I'm writing here the definition so that it can be more clear to you, right? This combination shows that the reciprocal of equivalent capacitance is equal to the reciprocals of, or to the sum of reciprocal of individual capacitors when they are connected in series, right? They are connected in series. Right? So what this equation shows, basically this equation shows that the reciprocal of equivalent capacitance is equal to the sum of reciprocal of individual capacitors when they are connected in series. However, we will have a different combination or different equation for the parallel combination or capacitance in parallel, right? So in today's video we did a numerical in which we got to know that how to find the equivalent capacitance. We can basically find that by taking, or we can find the reciprocal of equivalent capacitance by taking or by adding all the reciprocals of individual capacitors, right? That would gonna lead us to find the equivalent capacitance. In the next video, we're gonna discuss the parallel combination or capacitors in parallel.